Welcome everyone. My name is Marloes Reining and I'll be your facilitator today for the Regenerative Collaborative webinar on densifying cities with timber. We have some exciting speakers lined up. Now getting to the fun part. Welcome. Who is the Regenerative Collaborative? We are a non-profit organization and we're really focused on transforming our built environment into a regenerative one. We promote strategies and approaches that bring regenerative design and construction to life. We work collectively to inspire you guys, to educate you guys, and to create awareness and contextualize a regenerative built environment into a South African context. We really make an effort to showcase local projects, local people, and local companies that align with our goal, which is creating a regenerative future. So, all our webinars are available on our YouTube channel, so if you have missed one of the previous webinars, you can find them back on our YouTube channel. And while you're there, please hit the subscribe button. We really need all your likes. And when you're in the stalking mood, just also start liking us on all our other channels, Eventbrite, LinkedIn, and YouTube. We're 6 likes away on LinkedIn from 1,000 followers. So if you're not following us there yet, please follow us. It would be great to report on 1,000 followers next month. And then if you're not busy enough in your daily life, please consider joining our team and become a volunteer for the Rcsa. Any skills that you have will work for us. If you can help us with marketing, IT, or admin, whatever you feel like doing, we can use all the help we need. So please feel free to reach out to us. If you know of a company or you just got a big bonus at your company and you don't know what to do with the money, you can consider sponsoring us. We have different sponsoring options, but even if it's just a webinar, that's all good. So please let us know if you know anybody that wants to donate money to keep our non-profit going. So today we are talking timber and how we can densify cities with timber. We have 3 exciting speakers lined up. We're going to explore how tall timber and mass timber construction can unlock new regenerative approach to urban densification, enabling cities to grow vertically while reducing embodied carbon, construction disruption, and resource use. So we're going to start off with Damian. He's going to do the first presentation. And Damian is a technical specialist in urban development at SMEC, engineering firm. He's a consulting structural engineer technologist with over 2 decades of experience across residential, commercial, and industrial buildings, and a growing focus on low carbon and resource efficient construction systems. His work centers on modular and prefabricated building systems, as well as regenerative structural materials such as mass timber and engineered bamboo. Before joining SMEC, Damian founded and led his own engineering consultancy, delivering award-winning projects in collaboration with leading South African architects. We're really happy to have him here. He's one of our loyal followers of our webinars, and I'm really excited he can have his presentation today. And then he will be followed up with a presentation by Sebastian Bildau. Sebastian is a German architect, urban designer, and tall timber specialist based in Munich. His work is rooted in a bioclimatic approach to architecture, focusing on user well-being, operational efficiency, and passive sustainable design strategies. He has taught architectural design at Duke University in the US and has led major projects and master plans across Europe, North America, and South Africa. Sebastian holds his bachelor and master's degrees from the Academy of Fine Arts in Vienna, where he received the prestigious Karl Appel Award. We're very excited to have him here today and share his innovative thinking around timber structures and his experience in reimagining how cities can grow more sustainably. And then lastly, William. We have William also from SMEC, a technical principal for structures in SMEC's urban development division. William is a registered professional engineer with over 30 years of experience in structural engineering, having worked across commercial, bridge and building projects, as well as running his own consultancy before joining SMEC. It seems to be a theme in the, the thing, running your own consultancy before joining SMEC. Alongside conventional structural design, William has maintained a strong commitment to community-based and sustainable projects, working with natural and low-impact materials such as rammed earth, cop, and straw bale. He's lectured part-time at UCT and mentoring final year civil engineering students in design and professional advice. I'm really happy to have you here as well. I think what is interesting today is that we have a combination of architects and engineers. We usually look at more at an architectural perspective, but I'm really happy to have the engineers on board as well, especially talking about the timber side of things, because it usually looks pretty immediately when you use timber, but then how do we actually build it, and can we make it work from a structural perspective? So I'm super excited to have you guys here.
Sure, thanks. Thank you for that introduction, Modulus. I have been following your webinars for years now. So yeah, I'm really honored to be presenting on it today. So thank you very much for the opportunity. And just kudos for the work you guys are doing. I think it's fantastic, and good to see the all the engineers here. But it's also good to see all the engineers at the Wood Conference on Tuesday. For those of you that were there, it was an absolutely phenomenal conference, and it was really good to see the amount of engineers that were there. Okay, without further ado, let me get to sharing my screen. Right, guys, so urban densification with tall timber structures, and this little squiggle on here is the concept that's where we started off with on this journey with Sebastian. The one thing that his bio didn't include is how convincing it can be at twisting your arm to do work on the side that doesn't generate any money. So just before we embark on this, I just want to be clear that this isn't a real project. It's a project that's in a team's discussion that we were having after we had met Sebastian. We looked out of our office window and selected a building that we thought would be a great way to explore this idea of urban densification. And so that's where this idea was born. We embarked on this at first without even talking to the owners of the building. We have subsequently spoken to them, and they have basically allowed us to continue with this presentation and with this project of ours. Just aside from the title, that while the main character of this project is timber, that's not what we're actually focusing on. We're actually looking at strategies for urban densification in ways that can be done more eco-friendly, and instead of pushing out urban sprawl, finding ways to innovatively densify, go up and out in our existing CBD areas. So the main driver here, as I'm sure everyone on this webinar is aware, is carbon and carbon emissions. And that I'm sure all of you are also aware that our built environment is responsible for 39% of the global carbon emissions. And the built environment includes the building and running of our buildings and infrastructure around us. Now, of that 39%, 8% of that carbon emissions is due alone to the manufacturing of cement. And another 8% is responsible for steel. Manufacture of steel is responsible for. So right there, two of our biggest construction materials account for 16% of global CO2 emissions. And on the operational carbon side, while our colleagues, mechanical engineers, industrial engineers, and even architects and other professionals in other industries have done a phenomenal job in reducing operational carbon. For some reason, civil engineers and structural engineers seem to have got their feet stuck in the wet concrete, and our embodied carbon in the way we're building hasn't changed much in decades. The way the guys are building buildings in the 50s is pretty much how we're doing now in 2026, and that's where we're seeing now. Look, this really needs to change. So what we did was we picked this building. We're pretty much, yeah, it's pretty much ranked as maybe one of the ugliest buildings in the CBD, short and squat, but we identified something that we thought had massive potential. Now, the one thing what we need to be aware of is that the greenest building probably already exists. It's not going to be one that is built from scratch. A building that's built already has already done its damage in terms of carbon emissions. To break it down will release more carbon into our atmosphere, even if the building you're replacing it with is 100% timber. So we need to, at our starting point, need to be looking at our existing building stock and saying, how can we, as a very at the very start, look there and say what potential lies in that alone. Now, I saw a stat, I think late last week, by our Minister of Infrastructure, saying that they're about to release 88,000 buildings from government and sell it to the private sector. That's a lot of opportunity there for densification. So what we looked at in this project was selecting a building and seeing how can we push it upwards and outwards to increase volume and do so in an eco-friendly way, but also that improves the aesthetics and just generally improves the area around it. So I just want to spend a moment and talk about this building. This is the Atlassian headquarters currently being constructed in Sydney. This building, they're about halfway finished with it now, and this building is absolutely flying up. This building consists of a concrete core that runs all the way up the building for the elevator shafts and stair shaft, and then just right above those existing buildings there's one concrete slab. But then all the floors from that point up are all the floors, columns, beams are all mass timber. So this building, when it's finished, will be the world's tallest hybrid tower. By using all the timber, it's now sequestering 5,800 tons of CO2, such as a 50% reduction upfront embodied carbon. This building will also feature a transparent solar PV facade, which will generate all of its electricity, and it'll be harvesting all of its rainwater and grey water. So this building will be 100% renewable from day one, and it's taking care of both fronts being operational and embodied carbon. And this, to me, is a blueprint for the way any building from this point forward should be built. And if you're not building it this way, you can answer to the children coming up why you guys carried on when you knew there's a better way to do things. So yeah, just really hats off to the developers and the team behind this building. So what we're needing to do at this point is change our focus a bit. We need to move away from just being sustainable. We're now finding it's just not good enough. We can't focus any longer on just reducing harm. We need to start looking at actually restoring value in the buildings that we live and work in. So I just want to give a little background on how this our meeting came to be, just very briefly. So we actually met Sebastian at the Timber Construction Conference at the University of Pretoria last year. It's a very good conference, and for those of you who haven't been, please make an effort to get there this year. We got chatting to Sebastian after he presented there, and then in Sebastian's usual European way, invited himself out for supper with us. Which was great. I'm really glad he did. We're good friends now, and from that point he said, no, let's keep in contact, and so we did, and that's how we got to embark on this endeavor. So we've designed this building now to a point that I think would be the equivalent in South African construction terms of just beyond concept stage. We've got a concept together, something that we believe would be easy enough for where we could guide a QS on getting a cost estimate together, but we still need to take it further, and that's what we'll be doing. But Sebastian and William will talk about the technical aspects of that. So with that, I'm going to hand over now to Sebastian.
Alrighty. Yeah, thanks so much. It's really great to be here. You know, it's kind of like a marathon presenting this project, first on the Wood conference, and then did a small event yesterday here in SMEC's office. But you know, it's really great, and that's what I enjoy doing is you know, discussing this kind of concepts and you know, getting involved with all the different actors in the building sector and the owners and the people then using this kind of things. You know, just to get started with kind of like what my mindset is, and you know, it's not just looking at timber construction, but it's you know, going into material efficiency, simple construction, of course, circular, looking into blue and green infrastructure, and many other things we will discuss a little bit and touch on today. And then, you know, just to give you a little bit of insight what the projects beside the tower here, the Cresta Tower we're working on right now, you know, it's like from very small to up to 100 meters. You know, kind of like looking into tall timber towers. That's something what I brought from the US. You know, I'm not just coming here and you know, showing you what I do, but to every context I go and travel, I also try to learn from there, from you know, what you guys, for example, are working on here. I learn about your forestry, about your timber construction, what kind of species you're using, and what your topics are. So that's quite interesting to go into. And you know, since we are talking about density today, you know, one of the things I was really struggling with, for example, when I was working in the US, I was there for 4 years, and you probably have a similar phenomena here in South Africa, is yeah, urban sprawl. And you know, obviously we don't want to take away single-family homes from people, you know, like the Americans say, one family, one plot, one building. So I would like to suggest that maybe, you know, we take the family homes and not, instead of spreading it out into the countryside, we rather stack it up into a tower, you know, preferably in timber or in hybrid, or you know, it can also be rooftop extension, densification, adaptation of existing buildings, stacking up on existing buildings in any scale, or build ground scrapers. You know, if you just take the skyscraper or tall building and lay it flat, becoming a ground scraper. And you know, from my point of view, coming out of Europe, or you know, you have similar structure here in the CBD. You know, having urban blocks, and you know, at some point you need to stack these urban blocks, and you know, but keep the logic of it with you know, public ground floor with shared amenities being accessible to the public, and then you have a package of program with 4, 5, 6, 10 floors, and then you have amenities again. And then you know, what would happen if we stack this, becoming new vertical neighborhoods? Well, you know, these were the first slides, you know, about the topics, and kind of like the, you know, talking about the mindset and what are the important points we're working with, current projects we're working on, you know, kind of like, you know, looking into different scales, you know, one here in South Africa, one in the US, in St. Louis, Vienna, Munich, Frankfurt, Berlin, different scales. And yeah, you know, I'm gonna skip just because everybody knows what urban sprawl looks like. And then, you know, this is one of the concepts. You know, if you try to take a one family home with a garden, you know, here this is kind of like American scales, 9 by 9 meters, and it's not just the housing unit itself. Let's say it's kind of like a row house, you know, and you always have a garden, and you try to stack this into a timber shelf, let's say, and you know, add green And you know, it's just make the balconies a little bit bigger, maybe 9 by 9 meters, a little bit big. So right now I scaled it down to 6 by 6 meters. You know, they also, you have your kind of a private green as you have it in little row houses attached to your flat or to your building. And then, you know, you obviously have also shared terraces. And then, you know, we stopped here, I think, talking about the vertical neighborhoods. You take a city block and then just stack it on top of each other with the public amenities being, you know, shared amenities like gyms and restaurants, or their public greens, or just void spaces within the tower. I think that's quite important. And then, you know, I would also encourage you to think a little bit outside of the box. So this is a cool exhibition I saw from SOM in Chicago. And, you know, timber has this advantage. It's very easy to work with material. And if you cut it into shape, you know, we don't necessarily need to do very orthogonal buildings. And if you look at these kind of structures, or this one here in the middle, diagrid structures, they even perform better because they are making stiff triangles, and they're saving also on material, which is also important, you know, because precious material. And then, you know, just to kick that off, I would like to show you in a couple slides how we approach timber buildings. And one major topic is, I would say, is big picture and small detail. You know, it's, so this is what we architects like to do, is, you know, the image on the left, just making beautiful images. But, you know, it's very important that from day one, you also start thinking about the details and the connections, and, you know, how the fire resistance solved, and how does it meet the facade, and these kind of things. How big are the members? And then, you know, what I brought from school is structure as ornament, and I think that's also very valuable in timber construction, because, you know, obviously you have kind of like a timber frame houses we see in Europe and in other places, and they want to be exposed, you know, because if there is a problem with water entering the building, or some mold, or, you know, you see it right away on the structure. So leave the structure exposed, for example, for a post and beam structure, and then you know, if you do it nicely, it also becomes an ornament, let's say. And then, you know, that's a term we coined, that, or a sentence we coined at CF Müller Architects. I was there for 3 years heading the timber department. We said building high and build elegant, but also build circular. And, you know, this is a competition we did in Hamburg for a timber hybrid tower. And, you know, also already in the competition, we looked into the details of the gray energy and what kind of materials we're using. And, you know, it also affects obviously the design, whether you put aluminum panels on it, or what we ended up with recycling glass. You see a little bit down here, you know, it's even much better than recycling aluminum. And these kind of things, you know, please consider that also from the beginning onwards. And then, you know, when you look into design and detailing, also the manufacturing is very, very important. You know, talking to the manufacturers and installers, bring them in very, very early, even in concept design, to think about dimensioning, you know, where to put different members, screws, how many sheets of plywood or a drywall you need to put on, and how big are the modules, whether they're 2D or 3D, how are they transported to site, and then how they are put together. And the beauty of the timber construction, or prefab in general, whether that's steel or concrete or timber, is that, you know, as you put it together, more or less you can also disassemble it, you know, for the topic of circularity. But, you know, my point would be to rather leave the structure standing, you know, for, let's say, 100 years and more. And as we heard in the wood conference, for example, from Reinhardt, the stave church is in Norway standing for 1,000 years. So that's kind of like that, where we are aiming at. And then, you know, just to give you a little taste, I'm going to flip through quite quickly previous projects. You know, that's kind of like where I started. They call it a timber hybrid. Nowadays, I would rather call it a concrete hybrid, because the structure itself is the primary structural frame is concrete, with concrete beams and walls and slabs. And then the facade itself is timber, it's untreated large wood stud wall, and the separating walls are also in wood. And then, the balconies obviously as fiber cement concrete or fiber concrete hung onto the facade. And in this project, the big challenge was building is a 7-story building with a combustible facade. That was actually not possible at that time in 2011-12 when we asked for permit. And you see here these separators between the levels, that the fire, if there's a fire on the facade, it's not jumping the floors, and they're actually projecting, solid steel sheets projecting forward up to 15 centimeters. But it's very dense. It's social housing in Vienna, and Flugfeld Aspern is an old airport, kind of like a post-industrial site, which they turned into a new city quarter. It's very dense and very regular central corridors, and here you see the scheme of the mix of materials. And then it's very green. The green helps also with privacy between the blocks. And then also I chose this project talking about density in cities. That's a project I worked on in Montreal in Canada. And I was there for 2 years after my stay in Vienna, studying and working in Vienna. So from 13 to 15, and it's basically kind of like a European city block. It's a 4-hectare site, and the back pieces here or buildings are timber, and then we have some mixed-use development with light industries, offices, and retail. And we have this nice diagonal cutting through the side with 2 squares here as a kind of like a central urban forest. And the most important element is here the urban corridors, or green corridors as we call it, connecting the top park with a green corridor down here. So it's not just made nicely for people, but also for plants and insects and animals, and birds and so forth. And then, this square is also, it's not just like the lung of the development, but it's also, important to store snow. In Montreal, there's a lot of snow coming down. It takes quite some, if you pile it up into a big hill, it takes quite some time to melt. So you need to take this into consideration as well. And then, this is kind of like what I brought from Austria, let's say, working on this other project in Vienna, having units in the ground floor. Here, I guess it's also quite a security issue, and feeling comfortable in the city. And would be interesting to see how you are solving these kind of issues. But having units coming all the way down and facing the green corridor, we had a lot of discussion with clients about that. And then it's also kind of like an energy loop between the office building and the residential buildings, having different sharing energy and heat and cold between the buildings, and they're stored in the bedrock, which is right below the building. And then just to, it's quite cool to see how the whole neighborhood is coming together. I visited in 22, it's already quite some time ago, but they're nearly finished. And then just quick, the last image or last project here for high-rise in Hamburg, as I mentioned before. It's the Germans, they love their concrete core in the middle. So it's very hard to get around this. And since it's a 60-meter tall tower, so it's a security staircase, pressurized, or just one staircase, since it's pressurized, and elevators, and then the rest is all timber going around. CLT decks, glue line columns, and then the usual set of adobe boards and other renewable materials. The section we've seen before, the loggias and terraces, it's quite a challenge, because they're always cutouts, and the thermal skin is kind of like jumping in and out. So these kind of details, they're quite tricky to pull out the timber into the outside. It needs to be heavily protected. And then, this is what we did with the team at CF Müller to show, what kind of material mix we have inside, and then focusing also a little bit on the material selection on the inside, but also on the skin itself, and then showing what the overall footprint in terms of global warming potential would be. So it's a nearly 50% reduction to what we call a DGMB, similar to LEED in the US. I think you're using that here too. Then just kind of like final image, and with the crown, we will come back to the crown later. And then to look into the Cresta Tower, as Damien mentioned, it's a self-initiated feasibility study, trying to show what the potentials are, not as previous in the previous project in the new build, but using an existing building and trying to show what you can actually do with it and what it does in terms of how much more surface you can do, how you activate the building, how do you put more green, would you put a new facade, do you put more amenities on top, and so forth. And it all started with this small little sketch, and then with William, he will show it also in his presentation a little bit. We bounced back and forth digitally over Teams and other means, coming from the existing building, working on sketches and models, and then turn it into this final rendering we'll look at later. And then we focus a little bit on these besides the mass timber construction, what is this theme today, but it's also about prefabrication. It's a dense urban site. There's nearly no staging area, so if that's going to get built, we need to see where there's huge timber members are coming in. So this truss here is 50 meters wide and 75 meters tall, so they're quite some there's quite a size of these members. And then it's all prefabrication, mixed use. Obviously, it's a hotel, so potentially it could also be some housing, or just extended upwards with a hotel and for retail, bar, public amenities, bars, restaurant, and swimming pool on top. And then green the building, and since it's all timber and steel, it's all dry and clean. And I already mentioned the public amenities, and of course it's an adaptive reuse of an existing building. You're probably familiar with it, and I'm not going to talk about this too much. It's the Cresta Hotel here on, I need to cheat a little bit. Damien, can you help me? It's Loop Street and Strand Street, yes.
And Strand.
Yeah, that's right. So I was struggling a little bit. And then, so this is the existing building as you see down here. And then what we do is, since the tower is a little bit recessed above the podium, we're, there's this funny plus shape, and we're extending it forward on all four sides by 6 meters. So it's a roughly 12 meters deep, 6 by 12 on all the 14 existing levels above the podium. 3-level podium, and then we're putting 4 more new floors on top, and then we're coming in with, we're struggling now. We call it the super truss, and some call it the mega truss for the people who were at the Wood Conference. And so let's see how the naming will be. And then up here there's somewhere between 2 and 3 levels, depending on how you count, for bar, restaurants, and public amenities. Half open, half enclosed. Obviously, strong winds need to be considered in Cape Town. And then, here you actually see the windshield for the pool and the top floor. And then what we also do, we put a new skin on it. I brought the timber aluminum hybrid prefab unitized system from Rcsa. I will show you a little bit later in detail how that looks. So also the skin will be updated. Here, a typical floor plan. So you see here this new units. You see the terraces, central core, 2 staircases, a couple elevators. And we rearranged a little bit slightly. We don't have the full set of drawings. It's kind of like interpreting what was publicly available, and these are the kind of like in the middle, from floor 3 to 16, the ones we extended outwards. And then here in plan and section, you see what we actually extended, the 6 meters forward, and then the 4 floors on top. And you also see the green terraces there on every 3rd floor. This is a concept I borrowed or I brought from Singapore. It's nice to look at, obviously, the green terraces, but they also reduce heat island effect, and they store water, or kind of like a retention for water, on a hydroponic system, to not to put too much weight on it. And then, just showing a little bit more in detail how the timber frame is working. And William will touch on this a little bit in his presentation, but since we emptied out the whole building, built it kind of like back to the primary post and beam structure, we're able to put all this load on top of the existing tower, and all the horizontal or lateral loads will be induced into the existing building. Only vertical loads next to this, kind of like on the extension on the ends of the tower will be brought directly down, and then obviously there will be some additional footings and columns down here on the base. And then, just to give you a scale, it's roughly 1,700 cubic meters of glulam put in on the tower, and nearly 1,800 cubic meters of CLT with 20 centimeters thick floors. Then, some schematic details, how the floor would look like. And we also brought a system from Sweden. It's called Granap, and so this is the manufacturer. And, for the people who are familiar with timber construction, typically the timber deck and CLT, DLT, NLT, whatever system you're using, needs to be a little bit more weight needs to be put on the system, or you have a suspended ceiling, which has the disadvantage you don't see the timber from the underside, and you get all the biophilic aspects underneath. So this is a good combination, saving load and saving height. So that's quite nice. 15 centimeter kind of like floor built up on a raised floor, and the trick they're using, they're putting elastomer stripes into the raised system. There's different other systems, kind of like handmade, with elastomer stripes sitting below the footing of the raised floor, and we're trying to use wood-to-wood connections, not to put in too many screws or glue, or even put concrete to connect the different panels. There's the X-Fix, as you might know, and then the cone, which is just developed by the university in Kaiserslautern, Germany. And then, as reference, this is the existing floor using the same system, and since this floor is a little bit heavier in concrete, we only use 10 centimeters, so it's kind of like a reduced floor. And then, as a kind of like a further investigation, that's what we are trying to kind of like develop with the testing facility at the University of Pretoria, is looking into your local species with a system of timber concrete composite panels, it's timber and concrete on top, and then even better, white concrete, as I mentioned, was kind of like a preferred method, and using adobe in combination with timber or bamboo. And this is what we are trying to propose or to develop, is having two systems with the local species, with South African pine, eucalyptus, and then potentially bamboo. So that's forthcoming, maybe to be presented in a year or so in this format. And then, just to conclude, the crown, which is put on top, is needs to carry itself. We kind of like really reach the load limit, so to speak. So therefore, the crown standing on its own structure, which is put next to the building, and well, for now we call it a super truss, plus the crown, and then all the loads, mainly the vertical loads, are brought down directly in some of the horizontal loads can be induced up here in this section. We'll talk about this a little bit later. And then, the facade, as mentioned before, we're going to take off the existing kind of like a band ribbon facade and precast concrete panels, optimize also the kind of like the, how to say, operational energy of the building, insulating the skin a little bit better, and also bring more warm materials into the game. Obviously, coated with aluminum on the outside, recycled aluminum. Then, yeah, these are the first sketches. These are the unitized elements. Roughly, depending on what system you have right now, 2.5 meters, 2.5 meters by 3.5 meters. And the interesting thing is that these unitized timber curtain walls, they can even withstand your strong winds here in Cape Town. So that's quite nice. And then, just a couple of details. These are the details from the manufacturer, from Rcsa, from Germany. And then, here's kind of like the floor meets the facade detail with heat recuperation, fresh air coming in on this kind of like bench in front of the facade. Here's the element joint. And then, already mentioned the terraces, which are every third level. Here you see the image. It's a hydroponic system, Profiline. It's also a German manufacturer. And then, just to summarize all the sustainability measures, and, we also try to put it in relation to the ESG goals, what you see here on the left. And then to conclude, the material mix, it's not just timber on it, timber in all kinds of combinations with CLT and LVL, LV hardwood, beech, and then bamboo, potentially as a cladding, or using terracotta, and the facade system, acoustic suspended ceilings in areas where we need. And also, what here from your project at Harrington Street from Wolf and Wolf is the timber and the hemp combination. So actually, we kind of like developed this without, or myself at least, not knowing about the Harrington projects. And so I was really not surprised, but amused and really happy to see there's, kind of like you guys are working on the same thing. So it's just a little bit higher. So that's a quite cool, let's call it a continuation of the Harrington project here in town. And then, the KPIs, as the kind of like the developer investor talk is, it's roughly 14,000 square meters on the existing tower, what we estimated with the material we had access to, and we put 7,000 additional hotel rooms, 7,000 square meters of additional hotel rooms onto the tower. So that's a 50% increase. So that's quite good. And then we have an additional 1,500 square meters on the top, generating a lot of revenue. Yes, thank you so much for listening. And then I hand over to Mr. William.
Thank you, Sebastian. The questions in the chat are going crazy. So.
Oh, shoot. Okay.
Or the comments in
Hopefully
the chat.
We can answer them all.
William is presenting. You can have prepare yourself for the.
Okay, I will.
Good.
Right. So good afternoon, everybody. I'm William. I'm a structural engineer, and what I want to share with you today is the process, let's call it, that we have been through and are going through here at SMEC in our goal to make what we do more sustainable and to work on more sustainable projects. So to get a proper sense of that, I'd like to just start with where I started 3 years ago when I joined SMEC, and what we were working on, and how we have developed what we are working on and how we're working on it to get to this point where we are presenting this timber tower that we have been working on with Sebastian for the last, since September last year, when we met Sebastian at the Timber Conference. We are a consulting engineering firm, and we are the building structures department in the building plus cities function. The first job that I started working on when I joined here at SMEC was a hospital. This is in Limpopo province. It's a 5 billion rand hospital that's hopefully going to be built and starting to build in the next year to year and a half. And there are, in this image you can see, there are 7 multi-story reinforced concrete buildings and another 7 single-story buildings that are all part of this hospital. So when I joined SMEC, we have a very keen and eager team here in the building structures department, but quite a young team. There's myself and Damian being the old guys in the team, and there are a couple of other older people, but the bulk of the team, I would say, is in the 25 to 35 age group. Very keen, hardworking, but without our experience, but with a different take on how to do work. Anyway, we all got stuck in and we took this project on, and we did a lot of detailed work designing these buildings. Here's some of the deliverables. This is one of the buildings you're looking at here, that kind of details, and we were looking at the reinforced concrete, the structural steel, but on the reinforced concrete side, if you look on the right of the screen there, you'll see the sort of level of detail of reinforcing that we had to do. Most of us, when we started here, were new to Revit, so we learned how to detail in Revit all the reinforcing. And so for those 14 buildings I've just described, every single reinforcing bar was detailed in 3D in Revit, and that's what we learned to do. And it was quite a hard push to get that done, to deliver all of this to the quantity surveyor to go to tender. And we learned from that we need to find better ways, more efficient ways of doing that, how to use tools to be more efficient and also more effective and accurate with getting that done. And so that the answer to that came from the youngsters in the team. They come to me and saying, William, we need to start using computational design. We need to model differently. And so here's an example of what the guys in the team put together. This was one of the first things we did. Well, the first sort of proposals of how we can do our work, and this is a parametric model for a warehouse. So you'll see there are a couple of different options here, option 1 and option 2, and using Rhino and Grasshopper, we're able to look at different options and pull out numbers very quickly: kilograms, tons of steel, cubic meters of concrete, tons of concrete reinforcing, and so on. So we could use parametric tools and computational modeling to very quickly do the conceptual design, preliminary design for these kind of structures. We also looked at our workflows, our interoperability. And again, here, it's the young members in the team who've been driving this and pushing us and coming to me and saying, there's better ways. So what we're looking at here on the left of the screen is our Revit, how we would normally model. And we're using Rhino and Grasshopper to extract information from Revit and share it on other platforms, our analysis packages. We're looking at Tekla, Karamba, Procon, eTabs, Strand, and then take it back either through Rhino or other routes to put that information back through Rhino inside Revit, back into our Revit models, and be able to deliver to our client much more effectively and more accurately. Right, so that's one of the tools, one of the ways we're getting better at what we're doing, of the work we're doing. And so we use that in a project in KZN, or in Abu Dhabi, a flatted factory for a client called KZN. And basically what we received from the architects there in the top middle of the screen is 2D architectural layouts. We extracted the information and then used a parametric script to turn that into a 3D building. And from that 3D model, we were then able to, both on the left at the bottom, we've got our analysis model, and on the right, we've got our actual structural BIM model. And this was done within 3 weeks. We took 2D drawings, preliminary, well, pulled together the model, did an analysis and a design, and then used the model on the right, the Revit model, to generate drawings and deliver to the client a preliminary conceptual design, and actually the level of detail that we delivered to the client was actually much better than a conceptual design, so they could use it for pricing. But as hopefully you will notice, it's, well, let me tell you, this is a precast concrete building, so we're still dealing with concrete, all right, which is what we're trying to get away from. Another example of how we got better at what we're doing is how we're using our technology better is this Performing Arts Center for Kadia, where we did a peer review. And it's not, well, you can see all the people there, like little ants on the building. This is a massive building. We didn't peer review the whole building, just parts of the building. But the massive information that we had to get through, we couldn't have done this manually. Once again, if you look at the various parts of this building, there are these blades, they call them, which are these legs. It looks like a spaceship with these skew legs that are supporting the top of the spaceship. So if I could describe maybe a mushroom with a central core of reinforced concrete with this mushroom top, which is a lid, and the edges of that mushroom are being supported by these blades, but the blades are all skew and they put a torsion on the mushroom. So it's quite a complicated structure. And we were asked to look at this. These blades, these legs are all structural steel pages, if I can call it that. And here you can see some of them at the top, and then we can look at the concrete core in the bottom. There are theaters that are hanging from the core. It's quite a complicated construction. We need to now look at this, review this. We were asked to not only look at the structural design, and here you can see some of the output from the analysis programs, and review the analysis parts of the structure, but then also to check the geometry and the member sizing. So what we received was the ETABS models from the original engineer, from the design engineer, as well as their Revit model. And obviously the Revit model then generated the drawings that were issued for construction. They have now been issued for construction. But if you look in the middle at the bottom here, this is a drawing that we received. Now, we were asked to check the drawing, but if we sit here and go through each drawing individually, we're going to be here for months, and we had a month to get this done. So what we did was we used some code in Grasshopper to pull into Rhino on the left here, the geometry. This is just one of the levels. If you look at the you can still see in the background there the model in the slide at the back, and you can see this frame on the top in the middle, which is actually the geometry that we're checking here. And so you can very easily see what we did was overlay the frame that is in the Revit model and the frame that is in the ETABS model, and put on some code to show us. The green shows whether the geometry is in alignment. Of course, we have a certain tolerance. The red is where it is out of alignment and where either there are members missing or the geometry is not close enough. So that's the geometrical check. So you can very quickly, very easily see where there are problems. And then on the right-hand side of the screen, we've got the same sort of check, but instead of checking the geometry, we're checking the member sizes. So what we're checking is the output from the analysis, what member sizes are required compared with what is shown on the drawings. So again, very easily a visual display of exactly where, if there's a problem, where there's a problem. As you can see, there's a lot of members that the size doesn't exactly agree with from what the analysis says to what the drawing says. And then going back to that drawing at the bottom, you can see that we've gone and taken the drawing and we put these outputs onto that drawing so we can send back to the client a very easily understandable visual representation of what we've checked, where we found problems, and we found that to be an extremely accurate and effective way of doing our work. Right, but like I said, structural steel and reinforced concrete still. So we're not moving. We're moving in the right direction in terms of being effective with our work, but we're not moving in the right direction in terms of sustainability. Another tool that we have in our computational pack is the ability to take our building and put it into this kind of app and see, where is the carbon where is the problem? Where can we reduce that? So we want to be able to use that from our buildings. Unfortunately, if we apply that to that building, we're going to get a lot of red. Okay, here's the output that we can get from that. Right, so we want to work with timber. We want to do something in timber. We're going to these conferences. Both Damian and myself have a long history in our private practice before we joined SMEC of working with timber. And we want to say, well, let's not only do it for residential buildings, let's do it for large buildings. Where can we do that? And so in our discussion with Sebastian, he said, right, let's pick a window. And this Cresta Grande building is, I can see it from my office here where I'm sitting right now. He said, hey, there's a good building. We don't particularly like it, but we see a lot of potential in it. And here, this is sort of a workflow of how we went from looking at the diagram to going and checking out on Google Earth, getting some dimensions, doing some sketches. Damien went into the hotel's website and checked out their 3D walkthrough of one of their rooms and managed to find the floor layout on the back of the door. It was pure chance. He turned around in the 3D walkthrough and there was a fire escape plan on the door. So we got the layout of the floor, a typical floor. Then used the modeling to just sort of make a shape that we could play around with. That shape developed with some discussion with Sebastian to something a little bit more substantial. We put some blocks on top of the roof to have a look at that. Our hopefully iconic to be sketch of what the building is going to look like. That's from Sebastian. And then some discussions we had about these balconies, what you can do with them, where do they fit in, some more sketches from Sebastian, and our first model of what we call then a super truss, and then some more sketches from Sebastian, taking that now from Rhino and exporting it into an analysis package, and then using that analysis to go back into Rhino again, export the model to Sebastian. Sebastian used some very clever AI tools, and suddenly we had a beautiful looking building. So that's sort of the quick process. It's taken us a few months of discussions and so on, but in a nutshell, that's the process that we went through. So here's that initial program, and we play around. Here's the code at the top and what the shape looked like. That's what we played with. Then this is the code that we eventually have for the where we are at the moment model. Made it all nice and sexy with different colors here. This is not how an engineering model would really look, but this makes it a lot easier to follow the code. I had to put special effort in to use colors. And this is now the model that we have. So I am just going to try quickly to switch to my Rhino model to show you the Rhino model. On this, we're going to switch to the latest model because it gives us a nice view of that. Let's do a large objects unit as well. So let's just look at this. Here is what's there. This is the podium. These are the existing floors, and there's this bit sticking out the top. So we wanted to add on modules to the side and add on modules to the top. So I'm just going to switch. That's what the plan was in terms of additional rooms. To do that, we stuck some frames on the sides. We put some infill frames on the roof. We then stuck on these super trusses, some amenity floors on top, and also for good measure put some balconies in. Right, so this structure, the thinking of the structure is, as I think we've made it clear, we don't have access to all the design calculations and know all the ins and outs of this building. So from the floor plan and from our experience with buildings and looking at what we think the building is, how it works, we've done some earthquake designs using the existing or some earthquake calculations to calculate what would the existing building have been designed for, and then said, okay, well, how can we, with what we've got, what can we do to use the existing structure to still work with all this additional load? And if we want to use the existing lateral load system, we need to take out all the existing brick walls, the masonry clay masonry walls, replace them with lightweight walls. Hemp would be ideal for all internal walls of the existing building. And then we actually have the credit, if you like, to be able to attach our structure. We're taking the vertical load in this new structure on the outside, and we're taking the vertical load of the amenities on top with our, I like the term we heard the other day, mega truss. Not a super truss, it's a mega truss. So our mega trusses will support this top platform, and the lateral stability comes from the existing building's core once we've hollowed out the existing building in terms of the existing brickwork and replaced that with a lighter weight option. But if push comes to shove, we have actually designed, or I've designed this, done the design calcs for this mega truss, and we can take that additional load through the mega truss in terms of lateral stability. So if we tie our new structure back to the mega truss, we can take that lateral load a different way down to the core. So we've got options, but it's a conceptual design, so we don't have to go. Right, so back we go to the presentation. Whoops. Is it gone now? Here we go. So that's where we are. That's how structurally we are getting this to work. And so that's great, right? We're using timber, and that's sustainable. And I've just talked to you about earthquakes and so on. I think if we're going to be sustainable, we need to go further than that. We need to look at our mindset. Oh, what's happened here? Here we go. Whoops, sorry, this was the interoperability that I've just shown you. I'll show you going from there to the code, to our spreadsheets, back to the design, and back to the code. But what I want to show you is a short video clip. It's a minute long. It's working better.
2010 and 2011, we had a whole series of earthquakes in Christchurch. 180 people were killed, but it could have been thousands. The way we save lives is by having controlled damage in the buildings. So when the buildings sway under movement, there is some damage, and it's controlled damage so the building won't collapse. The problem is that the buildings may then have to be demolished. If you go to Christchurch now, the downtown is a wasteland, and what we learned was it's not good enough just to save lives. You have to design buildings so that you also save property. A low damage building is a building which can have some controlled damage, but it's in a place where it can be repaired. They came up with a low damage system for concrete buildings, and we took a look at that and we said, let's try that with wood. At the University of Canterbury, I have some Italian colleagues, and they're concrete experts with knowledge about rocking concrete systems. But I was testing wood, and we got together and they said to me, why don't we try the rocking system with wood? Every time we get just as good a result, if not better, than we got with reinforced concrete. If you could imagine a building which was built like this, whatever happens to the building, it'll flip back into position.
Okay, so that's another thought. We've just been talking, I've just been talking to you about the lateral support system and the design of that current building, but it's a reinforced concrete building. And so if something were to happen, we were to have an earthquake, the building would, I trust, have been designed to save lives, but after the fact, we'd have to rebuild, demolish the building and rebuild it. So there is, in this particular instance, a mind shift required in terms of how we design the building, that we want to design a building, and there is technology available to do that, that after the earthquake, after that occurrence, that we perhaps have to change some parts or replace some parts of the building, but the building jumps back into place. And so I'm seeing that as the next step in sustainability, is that we're looking past our current assumptions of how and why we design our buildings, and looking for better ways that it's not just using sustainable materials, but the thought behind the design is sustainable. And we're looking for ways to build better, build faster, build more accurately, but also build with the future in mind. And so I just have a short video clip here of a building that is in Amsterdam. It's Hotel Dugteren, and this is a prefabricated timber building. These timber models that you see going up, they placed 200 plus units in this building in 3 weeks. So that is where we can go with pre-manufactured prefab timber. I suppose it could be prefab concrete, but then it won't have the carbon neutrality in its footprint. But what I'm trying to show you is that with a change in mindset, a change of how we plan, how we organize, and not just about what materials we use, we can make a better product, a better design, and we can be more sustainable. Okay, so thank you very much for your attention. I hope you enjoyed what we have presented for you today. And that's it from my side for today. So let me find my, of course, there had to be a spreadsheet on the screen just for you guys so that you can see engineers. I do like spreadsheets. Okay.
Great. Thank you, guys. You guys have the opportunity to ask a question in person. So if there is an urgent question, you can put up your hand. But I'm going to take the liberty to ask the first question. Sebastian, there's a lot of technical drawings in your presentation, and I was wondering, does the creative process of designing with timber, is it different from designing from a normal building? And do you have to like constantly go back and forward with a structural engineer to make sure that what you have in your mind is actually working? What has been sort of your experience? I guess working with concrete, architects are so used to it, so you know they know exactly the thicknesses and the stuff. But like with timber, because
Right.
there's so many more dimensions and forms that could potentially be, you know, in your design. How did that change your design thinking and your process?
Well, you know, it's with other materials, you know, when you work with, as you mentioned, with concrete or with steel or other renewable materials, after some time you get a sense for the material, you know, what it can do. And so as a rule of thumb, for example, you know, for the height of a beam, it's roughly 1/10 of the span. So this is a good starting point. And then, you know, after like trying all these kind of different systems and analyzing it back and forth with the whole team in all these kind of projects, I've not counted all the timber projects I've worked on in the different companies. But you know, for example, I always start with a 6x6 meter grid, and you know, you have like kind of like a rule of thumb for dimensioning. You know how many levels you can stack up, so you get a feeling for the dimensions as you do with other materials. And you know, it's same for components like doors and walls and windows and so forth. And but you know, it's very helpful and very important, as I mentioned, to work in a big team. And you know, it's not so much tied to timber but to prefabrication, I would say. You know, whether you do concrete fabrication, it's kind of like same system, you know, because they have the same constraints of how do you put together how's a concrete prefab element, whether it's hollow or hollow core or hollow walls, which will be filled in on site and so forth. So it's same situation, I would say.
Nice. Anyone from the audience want to ask a question? I must honestly say there have been so many messages in the chat. I haven't really got the chance to pick out some. Yeah. Go ahead. I want to say Koi Boy. I'm not sure if that's your real name, but
That's Johan.
how is that, Johan?
You know, Google is really funny because there's so many names reserved. So somewhere along the line, you must pick something that stands out. So don't ask. But my name is Dr. Johan Jacobs.
Yeah.
I am highly focused on industrial hemp. I am currently busy with a very large, sorry, I can't switch my video on. I'm currently busy with a very large project in Botswana, where we are planning up to 300 houses. they are all around the 30 square meters. Now, in Botswana, there's not exactly many large trees standing for timber construction. So this is all industrial hemp construction. So my question really is to ask that you talk a lot about prefab, you talk a lot about timber. You have mentioned hemp, but my question then is, can your principles, your architecture be applied to a sustainable housing environment as opposed to a 30-story building with what you call superstructure timber? So that's my question. Can you scale your ideas down as opposed to scaling them up?
Perhaps I can answer that. Johan, both Damien and myself have come from a background of working with small sustainable structures, and we're scaling those solutions up. So we've already done the small solutions and we are looking at the big solutions. So it's not, we don't need to scale what we're doing down. That already exists. There's lots of opportunities for sustainable small structures, low-cost housing. We're working on a current project right at this moment with, and Damien's the one who should be talking about that, but with the University of Pretoria and in a township here in Cape Town called Langa. So if Damien, if you'd like to say something about that. But the answer to my question is we're scaling up the solutions to deal with the big problems here in the city. We're not suggesting this is the solution for Botswana, but there are solutions which we have done already for low-cost housing.
Perfect. Thank you very much. I have engaged with Damien and hopefully we'll chat soon.
Thank you for that question. I'm also very keen to hear more about your project in Botswana. Maybe you can come and present it one day at one of the webinars. Okay, then there was a question in the chat from, so I don't know, I only can say TN de Koning. Is there a sustainable concrete reuse agreement in Cape Town? I'm not entirely sure what you're trying to ask, so I'm going to ask you to unmute yourself and ask that question in the right context. Then, okay, whenever you have found the unmute button. And Diana is also asking, what wind speeds is it designed to?
Brilliant.
So I just did a quick calculation because it won't make sense when I tell you that it's 40 meters per second, but that would be 144 kilometers an hour is the base wind speed that we designed for. But then that gets factored and upped because of the height of the building, and there are all sorts of factors that get applied. So we work out a wind pressure based on a basic wind speed of 144 kilometers an hour, and then size, shape, height, and so on of the building.
Yeah. Maybe I can add to this. You know, the curtain wall was tested up to what was it? I think it was like 2,500 PA wind pressure. That's how much is that? That's roughly 200 kilometers per hour.
Well, 250 kilograms a square meter, Sebastian. It's a lot.
Yeah. You know, it's very powerful system. You know, so they're trying hard to conquer the market. I'm not sure if that's enough for this height, but to be further investigated.
I figured out it's Timothy.
Yes, hi.
Yeah.
Hi. Yeah, my question was, there's some of the floors are there's 10 centimeters pulled concrete in. Am I right? What I saw on the paintings, on the engineer paintings for the hotel.
Yeah, we have I think it's 20, let me double check. It's 10 centimeters is the floor built up on top.
Yeah.
And then William helped me with what we estimated is 25.
Current floor 250 millimeters.
250, yeah, 250 millimeters current floor.
That's existing
our
building.
assumption. And you know, we did the calculation with Granab, and you know, that's what they did for us. They're saying with 25 centimeter concrete in situ, or as in the existing building, 10 centimeters of the floor build-up will be enough. And you know, if you can also go with traditional systems in wet or dry system, which are similar, somewhere between 10 and 15 centimeters. You know, the dry system generally tend to be a little bit thinner. Then, you know, we didn't discuss whether that's activated, you know, with heating, cooling, but the potential is there. So that's within this thickness of 10 to 15 centimeters.
Okay. So I was always a consultant in infrastructure and water and green management for a group in the Netherlands, but I'm related to South Africa with my heart and with my life. And the Netherlands, there is a contract for the sustainable reuse agreement that you get 70% out of your buildings that you knock down, or roads, or all those kind of houses that you not going to use. And there's a lot of potential buildings or empty buildings that those are not used. They're all knocked down by Cape Town if they're not claimed by anyone. But in the end, it's just rocks and they reuse it somewhere else. But it's not a reuse. It's not a reuse of the material. Instead of mining new materials, mining new cements, and mining, you can actually get 70% out of your concrete as a reused product. But there is a sustainable reuse agreement in the Netherlands. I was wondering if it's already also getting loose in South Africa, if there is any agreement or a contract agreement.
I think
because
I can.
Mining, if you look at the numbers of the SDGs and the KPIs, mining is number one, and that's where you start. That's where you start. But getting 70% out of a reuse agreement, that's a very big difference in the end.
Yeah, I think I can respond to that, and Damien and William just can add to that if I'm not giving the correct information. But from the experience over the last couple of 15 years, what we've seen is that there is no agreement in place. There is no agreement, but we do see that a lot of the rubble that is recycled from site is being reused, either in road construction, mostly in road construction actually, or infill on sites. So just because it's an economical thing, contractors do it just by, otherwise they have to dump it and they have to pay for it. So what I've found in my experience is that it is done in South Africa without the agreement in place. But
that's spot on, Marlis. From what I've seen as well. So for example, I know that Robbie Ross or Ross Demolition, they throw just about nothing away. You can go to their yard and buy anything you can think of in their yard. But I also know that they recycle most of their material. You can go and see their crushing plant there. They crush everything and set it off.
Yeah.
Okay.
Great.
But they don't have any formalized system in City of Cape Town.
Okay. I just wanted to I had to giggle when William was presenting and showing his sexy slide, which is a bit of a different sexy than architects usually call sexy. So that was I really enjoyed that, and all the designs and the parameters. So I just wanted to ask you one question, William, on all that. With all those technologies, which like really like I get overwhelmed if I see all those calculations and those parametric design decisions. Do you find that using those tools, it actually optimizes not only like, you can not only like look at different types of materials, but also like optimizing the structure itself? Because I guess that's one of the biggest complaints around structural design is like they over design quite a bit. And I guess it's obviously from an insurance and like making sure that like the structure doesn't break down in all kinds of weather events. But like, would this kind of like modeling help you to reduce the amount of materials that you use in a building?
Marloes, the goal of what I've been doing with this project is we're still in preliminary or conceptual design here, so we haven't gone to this stage yet, but the goal would be to almost have a number crunch and be able to now very quickly and very rapidly, using that technology, using these tools, to be able to look at different options. And so, for example, what I have got on the code that you looked at earlier, I can see immediately the total cubic meters of timber in the building. And so I can do some structural changes and change how the building works slightly and adapt this and change that, because you change this and it changes something else. And that would be then to use the number cruncher to look at several different options and then optimize the output, or see what gives us the best result. But just remember that it's not always saving a couple of cubic meters of timber here or there that's going to give you the best result. The best result is a package as a whole. And so sometimes your constructability or your repeatability might give you a better benefit than shaving off a little bit of timber here and there. But using that kind of technology, we can get those answers very quickly. And we can almost do an AI, get the computer to go look at all those different. So like that structure that I showed you, I can change not just the sizes of members, but the shape of the truss. Look at a taller truss, a thinner truss, a different configuration of members inside the truss, and it's really easy to do. And immediately I can know, hey, this shape gives me a much better stress distribution and or usage of materials. So yes, that is the goal. That is what we want to do. Is we want to use that technology to enable us to do check what we do faster, and then once we've done that, to then be more effective in getting it from the design into the model, into those drawings that go out for construction.
Yeah, and I guess
also, if I can, sorry, Marlies, if I can add to that, it's what you have at hand is not just only the mass or the volumes, but it's also the carbon content and the pricing. And then if you see, for example, the whatever European spruce is too expensive, we switch to a local species, to SAP or to another species, and then you can go back and forth, and obviously the optimization is also part of that. But it's to have the numbers at hand for global for carbon footprint and for pricing. That's very handy.
Yeah, super interesting.
Well, if I could add one more thing to that, the one thing we've definitely seen was employing these computational parametric tools allows us to get some of the grunt work out the way faster and allow us to focus where it matters more. So where we'd have to normally build a separate structural model and a separate Revit model, now we can do all of those simultaneously and auto output drawings through this process, and that then allows us to spend more time on rationalizing and optimizing the building, where we should be focusing, not on title blocks and spreadsheets, or like I say, like drawing registers.
Yeah, drawing registers. Yeah. Okay, sorry, we're running out of time, and I don't want to encroach on people's evening too much, so I just want to close out the. I do feel like we need to have a part 2 to this discussion, and maybe later in the year we can do another webinar around this topic. For the next month, we have a webinar which we are going to do around waste and circularity and how we can close the loop. And we've got already one very interesting speaker from the Congo confirmed, and we're looking for another one, but that's definitely going to be an interesting one. And then lastly, a big thank you to our speakers. Sebastian, William, and Damian, thank you for spending time with us here, volunteering your time here, and sharing your experience with us. It's really, really appreciated from our side.
Absolutely.
And then, Johanna, I see your hand is up. Do you have a technical question, or you just want to make a comment?
Just a last comment, Marloes, for your next event. Around circularity and around environment, we have launched industrial hemp sanitary pads, which have got zero plastic, completely biodegradable, and doesn't impact landfills. So if you're looking for a presenter during the session, let me know.
Okay, maybe not for next month, but I'll definitely be in touch for a presentation, because I want to do one on hemp only. So I'll definitely be in touch. Again, if you want to join the committee, let us know. Sponsorship, anybody with too much money can just let us know and be in touch with us. Follow us on our socials, and that's it from my side. Thank you guys, really appreciate you attending the webinar, and hope to see you next month again. All right, have a good evening, and thank you, Damien, Sebastian, and William for being here with us today.
Thanks, Marloes. Bye, guys.
Thank you, Marloes.
Ciao, ciao.